Hi everyone, here's Simone from Unveil Studio and welcome in part 3 of Unwrapped Geometry. Today we will speak about sample geometry and here 3 examples. One of those is available for free in my Patreon and is this orchid. We will examine that now. The link to this project is in the video description. Okay, we have a beautiful 3D scene with a beautiful flower. And as you can see, I'm noising in real time a lot of vertices. My FPS is set to 30 because I'm recording, but this can run 60 all day long. There are some pros and cons about this technique compared to Unwrap. The first pros is that I do not need to rely to UV in order to read the geometry. Really nice. But there's a cons. I cannot change the input SOP at runtime. I need to pre-calculate. Then with pre-calculation, if I already get this conversion, that is actually the painful one from SOP to top. If I do it before the show, then I can perform because I already have the texture I need. But this is a cons. I need to work and I cannot just pipe any object. So this is a cons on my side. Then after the conversion, okay, I'm going in the point level and I'm asking for the index by creating a custom attribute in point level with their own index. This will be useful after because we need to sample those textures that from the conversion that come from top to top. I choose fit to square and have an index will be useful since we can then use a modulo operation based on the width of the texture. So we can sample a square pretty easy. The shaded example offer also the capability of use the switch mode of glsl that is not present in Python, for example. You can create it, but as you can see at runtime, I choose which normal I want to use. I want to have the flat normal that I'm sampling from here, or I want to have the faceted normals that are actually calculated in runtime in the geometry shader. You can use both. Or write your own that interpolate it. There is a readme with an explanation of what is happening. Please read it. In this example, I am using I'm creating the scene in SOP, super easy, and this is a really pro of this technique because you can just imagine, okay, I want to have this in SOP. Okay, nice. And then how can I animate it? I can animate it by using the technique I was using for the unwrapped geometry. Doesn't really matter since this it's a signed distance function. And inside this code we have a signed distance function that actually doesn't care if I pipe something else. So just okay, this point it's here. How far is it? Okay, nice. We have it. So we can use the same effector and build some really beautiful deformation. It took me one day to get good lighting. As always, in touch designer. Or maybe it's me, I don't know. This is a simpler example of the same technique. I am collecting all my most beautiful project I did, and I will make a big release on Patreon soon. Okay, let's zoom out. We will now try to rebuild this situation with our friend Taurus. For performances, I will now close those. There are many news to come. But let's first focus on what we are trying to research today. Yeah, no. Let's use a complex object. A fancy complex object is Krag. If you're familiar with Udini, you love Krag. Krag is a good guy. Look at it. Beautiful. Krag is a complex geometry. Krag is a complex geometry that has two attributes at vertex level. Nice. Okay, but since we in the GPU, okay, and all this kind of pipeline that I call unwrapped geometry is my approach to vertex shader that are like the, for example, an example a really evolved mesh shader, pardon, is the Nanita in Unreal. You're not dealing anymore with something that is a 3D object. You just say, okay, this 3D object is a shader. And you have a shader. Okay, so we can do this in Touch Designer with tops, kind of, no? So instead to write, we can use top, and this is why I'm doing this, to try to implement a sort of way to have mesh shader in Touch Designer. And this is the sample geometry, is a way to implement the GPU calculation on point and send it to a raster. This is what a mesh shader does. Okay. Okay, brief explanation why I spend my time on this. And yeah, let's do a point. Okay, but before, yeah, we need to speak about. So we need, in the GPU we have points. Okay, so we everything we need now we needs to be in point level. And what we need, point are already in point level. I mean, they are points. And but here we do not have normals at point level, and this is bad for our pipeline. Everything needs to stay in point level. So in the bigger house, because after we can derivate the vertices and primitive, but if we have good points, is always a good start. So I will drop now here an attribute create in order to pass to, let's say, promote, that is actually deleting and recalculation. I want to move this vertex attribute normals in point level. So with the bottom derivative give us the opportunity to do it. Pretty neat. Okay, custom point. So now we have the point, and first right here you need to have the whole amount of point. So if you want to do for operation on this SOP, you need to do it before to ask the index. In order to ask an index of point, we can use point SOP, call an index, and refer to the first input and read an attribute. Me dot input point, and point without a number refer to first input. They sometimes do it tricky, and then ask for the exposed attribute. The SOP class has this guy index. Nice. And this is our object. Okay, then the painful translation. SOP top fit to square RGB copy, take a position, ask for normals, Now look what happens if I do this. Error. Why? Because this guy read points. Only points. They don't care. Do you want primitive? You need to pass for do you want primitive data? You need to pass through that, and will be even slower. So be smart and recalculate it. If you want facet normals, I show you how to implement it. But these anyway give smooth normals that are really hard to catch at runtime, just by starting from point. Okay, I'm creating some null in order to be precise and know what I'm dealing with. I make also name. Okay, this is representing our position, this is representing our normals, and this is our 3D object. Okay, so we have now the same situation of the unwrap, but sadly passing through the CPU, since between this and this there is no render. Okay, but let's now use this render. Okay, let's use the render. So in order to use the render, we need to drop a geometry and render the geometry can have materials. Pretty good. And for our crag, I will choose custom color white or a little bit gray, like that. Nice. Then please derivative, give me the code of this beautiful phone you wrote for me. And I guess someone from the office say, hey, take it, tack, and we have it. Pretty neat. You delete this one, you apply that one, and it's the same. But this is written, and we can use it. Let's first compile the vertex shader as required. Okay. Let's first compile the touch designer as required. We need two buffers. One is for position, one is for normal. This is called as pose, this is called as norm, since the S is a must and it's better if you use it. Then what else? We need the width of this texture, and I will explain why in a second. Then we need the width of they match anyway, so you can just pick one of the two. Nice. Okay, we wrote this expression, and we ask the top class to give the width. That is an attribute, and we can have it. Now the attribute is converted to a vector, and we can have it inside this guy. What else we need? We need to read the index, okay, and declare this to buffer. Let's do that. Let's first make the boring part pretty fast, and then we go to paint and we try to visualize. So uniform sampler 2D, because it's a texture and this has pause. Thank you very much. Copy the line, change the name. You have now to sampler. Normals, yeah. Okay. We need also a uniform that I want that it needs to be an integer, and this is the width. It is better than a float in this case, and also because it is an integer. I want also to refer to the SOP, how to get something from SOP word, how to read an attribute in a vertex shader. You just type in, then you make you choose a type for the attribute you want to read, and then you just call it for the name, since you can do this, and if type and name match the given attribute, you have it in the vertex shader. Okay, we are now writing the formula, the formula, the line of the glsl that allow us vectory my pose, that will allow us to read pixel by pixel a texture, a sampler in this case, and the trick stay in how you sample as most of the time. How we want to sample this? With this expression. Yeah, okay. Why I wrote this? Okay, this is for later. We have now a square texture. Okay, actually a proper square texture. Okay, with the uh, tiny pixel inside. Okay, we know that these pixels are representing points, so the total amount of point we can get it from the index. And for index, I'm referring to the attribute, and I will call this index in our for later I. So okay. Then we have this texture being a texture as a width. That being a square is also is height. Okay. So then this index imaging as this index is a long line. We need to break this long line in pieces long as width. W W W, and this is index. So by breaking index in pieces of W and smashing one upon the other, I can read the texture. I create a sample, a sampling point that match how the texture of touch designer is built. Okay, this way. What is the mathematical operation that does this splitting for us is the modulo operation. So our sampler, the x, because we are going this side, is x, will be I modulo W. Nice. I back to, because it's a 2D texture. Okay, nice. Okay, then we need also the y. Okay, so which is the mathematical operation that tell me how much time this W stay inside index. You should know it is division. So I divided W. And we have explanation for this. Okay, we have an error because I didn't switch out the of course. Okay, this gives back a vec4 and I declare a vec3, and we need a vec3 since position normals are vec3. So copy the line, type change the name, change the sampler name, and smash the vector where they need to go. So in my case is line 39. I mean, is where the TD deform is called on my pose in order to create workspace from south space. Nice. And then we take my norm and we go in here, and afterwards the shader is done and we are good to go. Okay, no changes is nice, but if we now no changes is nice means we didn't break nothing. That is a big result. It's exactly what we want. Okay, hi Craig, how are you? You are now in Touch Designer. You're to the uncle, with the uncle. with the real-time icon. Okay. Okay. Now, another downside of this pipeline is that if you want to keep smooth normals, okay, you need to double the pipeline of deformation. That is not really cost efficient most of the time. And also, since the point are like not in a right order, okay, you should do it with a point with the sort, with the sort, but this gives bad side effect. The noise is applied to a things that doesn't really match the how the real position of the point you have it on the screen doesn't match it here. Okay, it matches better when you unwrap it. But yeah, so you need to really pay attention on how you are dealing with like noises. Okay, you need to make it really large and maybe play a bit more with harmonics. Okay, and you need to repeat it. So for now I just do this. Okay, and I'm also actually connecting the second point, the second input, because I'm trying to say, okay, this use this as UUV as well, so the output get less messy. And you can also see that if I do this, I have not correct normals. If I repeat the deformation, and I have a little correction, that is what the normals are there for. Let's animate a bit this crag with this expression 45. Okay, so we have now a crag that is under the water. Okay, so now, okay, can we do somehow find a solution about this and just a smash point? Yes, yes, but we need another compromise. Okay, so the other compromise, cheap compromise I found, is that we will now create a sort of facet effect. What is a facet? A facet, faceted normals. Actually, this is what we want to create. You have it by doing this. Okay, you can have it actually in multiple ways, but the one way that I can show it here, the result is with facet SOP. Okay, and we will get these kind of normals. Right, those kind of normals can be calculated for free, kind of for free, after tessellation in Geometry Shader. So we will also notice that we will have triangles instead of quad. And yeah, well, so we now want to bypass this, but not here, here. Oh, more problems are coming. Okay, so what are geometry shader for? Okay, geometry shader take primitive after tessellation. Since, okay, usually I have a mesh that needs to be a polygon in order to access its own primitive, okay, in SOP context. In the GPU, you have a tessellation thingy that take whatever object and based on how you teach them with the render, and in Touch Designer can read, I guess, triangles, point and line, and not quad, if I'm not mistaken, not sure. We have these three type of primitive directly from the GPU. Even if you use a mesh that has one primitive, automatically everything gets triangulated. The video card has core that does this for you, and you can access it, but not in Touch Designer, sadly. Okay, this is called tessellation. Okay, then vertex tessellation geometry. We will work here now. Let's finish it. Here we have the raster. Okay, that is a bunch of matrices that take point and calculate where is the camera and smash like a wide shape full of good things for the pixel shader, because here we are still in geometry. Okay, the rasterizer, that is this guy, render, and the rasterization process is this line here, tiny. Okay, this guy here is, we have now something on the screen, and we need a shader that can understand what the screen is, what the frame is, and can color pixel. Okay, so 3D, 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 conversion to 3D to 2D, and actually all the why you have something on your screen and which color should have the pixel you are seeing. Nice. So this is the pipeline. Okay. So we arrive here in the geometry. The geometry works with primitive, wherever primitive. Even if you're meshing, you are throwing in a mesh, this get tessellated, so you get a primitive out of it. Nice. Since I gave you the working example, I don't feel bad if I go there, the code I wrote, not here, but here. Yeah, come here to me. Let's be sure we're in the right one. Okay, I will zoom a bit. Okay, we are now in the geometry shader that work with primitive. If you don't know what primitive are, this is maybe not a good tutorial for you. So triangle stripe, and this is what we're passing to the pixel shader. This is what we're getting from the vertex shader. So we are getting triangles. Nice. So this is why maybe triangles 3. Okay, what are we looping here? What are we looping? Are you made of triangles, crack? No, you're made of code. So let's do a fast example with a sphere that we translate to polygon, and then we call a sub2 primitives. Okay, we're looping those numbers here, all vertices. Okay, this is why we have a 3, because this is made of triangles. And anyway, everything after tessellation is triangulated for the render of touch design. So it's this kind of API. Okay. So we are looping for these 3 vertices. So for each row, we go for each row that are all the primitive, and we loop 3 because this is made of 3. And anyway, we get triangles because they are declared here. Okay, pretty nice. Usually, this guy is taking what is coming from the vertex and say, I do nothing. There are primitive, beautiful primitive. Please, the pixel shader, give a nice color to them. This is what usually does. But can do more if you tell him to do more. Okay, we arrive now to the needs of calculating some normals. Whew. Triangles, brushes, A, B, C, normals of triangles. Okay, normals, we want actually this. Okay, this is our n. Okay, the normal, this is a 90 degrees angle. 90 degrees angle. Okay, we want this, we need to get it. Okay, we know that there's a formula for it, but work with vertices, works with vectors, and we have point. If I subtract 2 points, then I get a vertex. Okay, that if I subtract 2 points, then I get a vector. Okay, then what we need these two. Okay, because we are looping each one of these. Okay, and so I can even say I want to have this and this, but I like C as starting point, just to be different. And so what we need to do, we need to make this. The formula is the normalize cross product of CA and CB. Okay, so the normalized cross product of CA and CB will give me n equal. Okay, and this is our primitive. Nice. Let's write it. I think I copied for a reason. And this is how it's written in code. Okay. I and it's also a bit hacky how I did it, since I was having 32-bit float percentage error, so the normal was like calculating everything inside of the object and everything was like getting disaster. This was not happening with OpenGL. And I needed to somehow do this percentage one. I don't know, with this I got a really good facet. That's what you are supposed to have without this percentage. But take this with a bit of imagination. Okay, so this is referring to point A. I vertex space pause is coming from the vertex is a point. Okay, this is C. This is A. This is C again. And this is B. Where are you going at the end? This is B. Okay, oh, you got the point. Okay, so now we can say, since we are already using the I here, we can say facet. And we have a faceted crag. And I can even do this, and crag doesn't care, because those normals are calculated here in the geometry shader. And if we zoom, not with the light but with the camera, you notice that here we have triangles anyway, because we are after tessellation. And here, by starting point, no, by the facet I was doing actually. I don't share points instead of primitive, and I want to recalculate the normals based on those points that are not shared. I got quote, because actually this guy is made of quote. Okay, but after tessellation I got triangles, and I need to calculate the normals from them like this. Okay, so this is all about sample geometry. Hope we'll unleashing you a lot of nice idea on how to deal a bit with geometry in Touch Designer. Please stop doing particles, because you can do more than that. Happy programming.